Now, that's one of them. The other one is the fact that there's different ways to form discrepancies among log likelihoods. We're picking the one that's also the most tractable and the one that's got the, and this is the one that shows up in a bunch of other literatures as a consequence, all the way from large deviation theory to other literatures. It gives rise to these exponential tilting type solutions that are nice, simple, and tractable. So we're also, in some sense, using them for that reason.
I mean, if you use, say, Blanc criteria
Right.
for testing across non-nested models, which is an adjusted likelihood, is that a different measure?
Okay.
I mean, I guess the two questions are.
So what this does is this is a measure between two models. Imagine you have model A and model B, and you just want to get some measure of how far apart they are.
That part I understand intuition.
So in that sense, so in that sense, it's like Bong, and then the only issue is kind of Bong is a log likelihood ratio averaged against something. It's only an issue of what you average against. Where whenever we do a hypothetical alternative model, we're going to do our averaging using that hypothetical alternative model. So I've got model A and model B. If model B is my benchmark, whenever I change model A, I'm going to use, when I form averages, I'm going to take model A to doing the calculation. In that sense, this is like a discrepancy measure, not literally a distance measure. So it's not symmetric, so it matters which one you pick as a benchmark. That's the awkwardness of it, but it's much more tractable than other ones. And in a lot of our calculations, that distinction doesn't seem to be so important.
I mean, Bong has a statistical criterion for judging
yes,
a
log
certain
likelihood
level
ratios.
of statistical significance, whether something is detectably different or not, right?
Right. Yeah, he's looking at log likelihood ratios, and for non-nested models, this is going to be the same thing.
Similar to that. You're throwing out the ones that are distinguishable, and then you're left with this class.
The class of the ones that are hard to distinguish,
statistical criteria, or
right?
Okay.
It's very close to Bong as a way to lead models in the table.
Right.
So imagine you're sitting here, you've got a whole data history. You're looking at models that have log likelihood ratios relative to the model you're using that are small and in a long-like sense.
And then the next step is to see what consequences they have for decision making.
Yeah. Right. Yeah. Right, which is kind of not part of Bong stuff. This is a whole literature in econometrics that people like Chamberlain and Mansky and others have been pushing as well. It's maybe we need to get decision theory, the consequences of our actions back on the table when we're doing econometrics.
And so what's the criterion? It's sort of which does worse.
Okay, so what you do is you take your decision problem, what your aims are, you bound this set of models, and then you figure out. You make sure your action does well over that whole set of models, and so that ends up doing basically what you do is then it's like it ends up becoming a min-max problem because you go through and figure out what's the worst that can happen among this class. So if you don't bound the class, you can find yourself guarding against stuff that may be really stupid here, and so the whole thing is to try to guard yourself against stuff that's subtle and not stuff that's obvious.
And you've done this, you and Tom and others have done this for like making decisions in asset markets and.
Well, also with monetary policy paper. Friedman's long and variable lags. We'll talk about that. I mean, Friedman's argument for passive monetary policy partly was we didn't know anything, so therefore we shouldn't be doing anything very bold. And that's not quite fair to his argument, but it's not too far away from that. And so apparatus like this at least gets you to think about issues like that as well. And if you look at Rogoff's argument for why you should do fiscal stimulus, he says, well, we really don't have good empirical evidence that fiscal stimulus works. But on the other hand, it may not be that costly to do it, and so why don't we do it? It's pretty much like a double robustness argument. I'm not sure I buy it, but that's his argument.
I don't quite understand why you talk about the scaling of the penalty by dt or by tau as something ad hoc. Because when you think about the non-recursive problem, and you write down just the value function plus some penalty that consists of this entropy measure from 0 to infinity may be discounted so that you don't run into this infinity problem. And then you carve up this problem to make it recursive. Then this scaling comes out naturally by from the construction of the recursive problem when you consider a period of length t or dt or tau as being the one period in the recursive formulation.
Okay, so let me take two responses to that. The first one is we certainly agree that scaling is ex post natural. That was supposed to be the message of the paper, so we're not disputing that at all. The paper, if you look at the predecessors in this work, like the Klebanov, Mukherjee et al., they never use motivation. They never use robustness and likelihoods as their motivation for how to calibrate ambiguities, and that's what led them to this. They were treating a parameter as kind of invariant to what the interval was that corresponded to what I talked about here. That's what led to the observation by Skiatis and others that in the limit their smooth ambiguity vanishes. And so part of this was an observation about that, but the other part is if you're going to scale the penalty, I agree. You have to think hard about what it is you're penalizing, which is I think exactly what you're saying there, and I certainly agree with that. That from the standpoint of statistical discrimination, the scaling we're doing is a natural one. I would absolutely agree.